Hi, for day 4, what we're going to talk about is the centroid in a triangle. Now, this is actually something that we took a look at way back when we did constructions. When we did constructions, we learned how to construct the centroid, and then we actually did a few algebraic problems that went along with this. So we've done this before, but back then it was in the should do section, and so some of you didn't attempt it at that point. So now it's in the must do, because at this point we absolutely have to be able to do these problems. So just a quick reminder, the centroid is where the three medians meet inside of a triangle. So again, just another reminder, a median is a segment drawn from a midpoint to the opposite vertex. So in the triangle down below, if I want to draw a median, first thing I'm going to do is construct a midpoint. So I'm going to put a midpoint on a side, and then I will draw a segment that goes from the midpoint to the opposite vertex or the opposite angle. So that line, that segment, is actually a median. Now, on the next page, we have all three medians drawn on the circle, or sorry, on the triangle. And what we want to do is see if there's some sort of a relationship here. Now again, we've done this before, so if you remember, that's great, but if not, we'll just kind of review. First thing I'll do is go to measurement, and I'll measure the length. Now, I'm going to look at D to G, and that turns out to be 3.1. Now I'm going to go from G to C, and that's 6.21. And then I'm going to look at the whole thing that goes from D to C, and that's 9.31. So what I want to do is see if there's some sort of a relationship here. Well, if you look at the short piece and the long piece, what you should notice is that that short piece of the segment is half of the long piece. So when you have your three medians that meet in a triangle, they meet at this one point. That one point is called the centroid. The centroid breaks each median up into two pieces. You have a short piece and you have a long piece. The short piece is half of the long piece. So on the next page, in a triangle, the centroid separated the median into two pieces. The smaller piece of each median is half the long piece. And then I have it written down at the bottom so that it looks more like a formula. Alright, next one. This question actually wants us to solve for y. So if you look on the picture, it tells us that the length of UT, so this piece here, is 3y minus 3, and then BU is 24. Now, we know, again, that the short piece is half of the long piece. So the short piece is 3y minus 3, and we know that that is half of the long piece, which is 24. So really what we're doing here is trying to solve for y. If I try to clean this up a little bit, 3y minus 3 is equal to half of 24. Well, half of 24 is just 12. Now if we go to solve it, we want to add 3 to both sides. So we get 3y equals 15. Divide both sides by 3, and y turns out to be 5. So again, we set up a little equation, and then we can go through and solve for y. Okay, this one was actually a Regents question. I wanted to put this on here just so that you can see how they could ask you this on the Regents exam. For this question, they tell you that you have triangle ABC. They tell you that you have medians AD, BF, and CE are drawn and that they intersect at G. Notice that they did not use the word centroid. So what they're expecting is that you know that the medians meet to form the centroid. Then they told us that EG, so this little piece right here from E to G is 2. What's the length of GC? Well, if EG is 2, the short piece is 2, the long piece is 4. Okay? Alright, next thing we're going to do is just review altitude really quickly. The altitude of a triangle is the height, or more specific, it's a segment drawn from a vertex which is perpendicular to the opposite side. So what I want to do is draw in a perpendicular line that goes perpendicular to this side, what I want to do is construct a perpendicular line that's perpendicular to that side and goes through that point. Now, another thing is that your altitudes are not always going to be inside of the triangle. If I go perpendicular to this side through that point, notice that my altitude is all of a sudden outside of the triangle. And same thing here. If I go perpendicular to this side through that point, my altitude is outside of the triangle. If I extend them, okay, they actually intersect out here at a point outside of the triangle. So sometimes your altitudes will be inside the triangle, like this one was, and sometimes they're not at all inside. Alright, on the next page what we're going to do is construct a triangle that has a median, an angle bisector, and an altitude. So here's our triangle. I put parallel lines here just so that when we go to move things there's some sort of a limit to the triangle. So that's the only reason why those are there. So again, first thing we want to do is construct a median. So we need the midpoint. And I'll just do the midpoint of that side. And then I want to connect it back to the opposite angle. So there's my median. What I'm going to do is make that a little bit better. I'm actually going to label this point as M. Actually, I'll just call it median. So that's the median. Then I'm going to do the altitude. So altitude is a perpendicular to this side, and I want it to go through that point. And again, I'm going to put a point down on the bottom where they meet, and I'm going to call that the altitude. And then the last one that we want to construct is the angle bisector. So again, construction, angle bisector, and then we have to outline that angle. So I'll put a point where the angle bisector meets that side, and then I will label it as the angle bisector. Alright, so now what I have here are three segments. I have the median, I have the altitude, and I have the angle bisector. Now, what I want you to notice is that usually in most of our triangles, the median, the angle bisector, and the altitude are three separate segments. But there is a special case where they become the same segment. Okay, they become the same segment right here. So what I want to do is see what kind of a triangle this is. I'm going to measure the length of the sides. So from here to here is 18.9, here to here 19.1, and here to here is 24.3. Now, one thing is that the 18.9 and the 19.1 pretty darn close to being equal. Again, the closer I get to actually being one right on top of the other is where I get those two to be equal. So the altitude, the angle bisector, and the median all come together to be the same segment when you have an isosceles triangle, when you have two sides that are equal. Again, we talked about that back in the video dealing with equilateral and isosceles triangles, but I just wanted to talk about it one more time so that you really make sure that you remember that. Okay, so what did you notice on the last page? Usually the three segments are different, and then when are they the same? They're the same when you have an isosceles triangle. Okay, so that is it for day 4. See you tomorrow.